Assalamualaikum. The classification for Sentinel Analysis Model. The title is Review on the Film Parasite 2019. The first presenter is me, Muhammad Al-Anik bin Abu Bakar. The second presenter is Nur Dayana. The third presenter is Muhammad Sahidan Farhan. And the fourth presenter is Amir Imran. This project was provided for Madam Rozian Niwati. The case study, Gisanchong, or well known as Parasite, is a film from South Korea directed by Bong Joon-ho. Parasite is the first non-English language film to win the Academy Award. The film was considered by many critics to be the best film of 2019, as well as one of the best films of the decade, and is the 46th highest rated film of all time on Metacritic. Metacritic is a review aggregation website for film, television, music album, video games, and books. The problem statement is to investigate whether the movie is good and can be accepted by other countries as the best movie since they won the Best Picture at the Oscar Award. In this project, we want to determine people review about this film, whether it is positive or negative review, since it is the first Asian film to win the award. We have three objectives in this project. First, to classify the review into positive and negative using the rapid minor, to determine the best training model to be used for classifying the testing model, to determine the percentage of review, whether it is positive or negative, using the Tableau apps. The problems that we have faced, at first, the data that we obtained was less than 600 data, but we managed to solve it by finding the data at 1 MDB data and get a total of 813 data. The process to create the model might be difficult due to most of the data is unstructured data. It requires more time to find the best training model to be used in the testing data in order to classify whether the review is positive or negative review. The next step is the methodology. First, we collect the data from three websites, that is Twitter, Rotten Tomatoes, and 1MDB. The next step is data processing, where we process to clean the unnecessary data in the data that we have collected. The third one, data modeling, where we compare three models, that is naive Bayes, random forest, and decision tree. And the fourth is data visualization, where we visualize our data by using the Tableau apps.
So now I will present the process for data collected in this project. There are three sources that the data is collected for the Parasite film reviews, which are Twitter, IMDb websites, and Rotten Tomato websites. A total of 1001 data collected from the Twitter, 184 data collected from IMDb, and as much as 457 data collected from the Rotten Tomato website. The reviews that are from Twitter are basically obtained using the rapid miner connected with the Twitter API via the search Twitter operator. The keyword used here is the Parasite movie with the limit of 1000 data, and the language is set to English. By using the rapid miner, it resulted as the picture beside. It can be seen that there are 11 attributes in total, which are created from user ID, to user ID, language, text, geolocation longitude, and retweet count. There is also one special attribute, which is the ID attribute. But in this project, the class level should be the text attribute, but I will explain it later in the data processing process. The data from the rapid miner need to be saved in Excel file. So the right Excel operator is used in this process and resulted in this. So this is the right Excel operator. Next is collecting data by web scraping. The second and third resources for this project are from Rotten Tomatoes website and IMDb website. And as can be seen here, this is the website of the Rotten Tomatoes with the data that we need, which is the reviews for the Parasite film. This step started with web scraping process on the Rotten Tomatoes website using Anaconda. We need this review only from the website, so we need to find the correct division as the coding shows. We create a CSV file named project as can be seen here, and the data is then collected in one CSV file. This is the result after web scraping process from the Rotten Tomato website. The data from IMDb are also obtained by using the same method. Both of Rotten Tomatoes and IMDb is then saved to an Excel file and is combined with the data from Twitter earlier for the next process. And now I will explain the data processing process. As I said earlier, the class label should be the text attribute. Thus, the other attribute need to be removed. Since it is from a website, the data type is unstructured data, and the text also consists of meaningless information like add, retweet, emoji, and etc. The data must be clean, leaving only the text review. Data text review that is not proper need to be changed into a proper review without changing the meanings of the data. Data that are not related with the Parasite film review will be removed. Next, the data is then classified whether it is a positive review or a negative review by only doing the tagging manually. The data is then split into training and testing with 489 reviews and 250 reviews respectively. In this slide, we are correcting some of the words that are often written in short form, such as ain't to is not, aren't to are not, and many other more. So in this slide, we only want the text attribute. The other attributes need to be removed. So we are removing from user attributes, from user ID attributes to user attribute, to user ID attributes, source attribute, geolocation latitude attributes, geolocation longitudes, leaving only text attribute, retake count, ID, language, and when it was created. As I mentioned earlier, the data must be clean, leaving only the text reviews, without the meaningless data such as ad, numbers, website. So we are removing all of that by using this code from here until here. And resulted in this. We then save the data into another CSV file, as can be seen here, the witchy file, and resulted in this. For the next process, Amir and Saiden will explain the next process. Thank you.
The process of visualizing the data. Before we visualize, we must make sure the data that we need to visualize must be clean. Then the first step is we must split the text data into word. The data can be easily visualized using the word data. There are two types method that was used to splitting the text data. First, we use the Power Query and splitting column in the Microsoft Excel. Next, we using the Tableau. First, in Tableau, you must insert the text data in text file and use the function called text file properties, and it will help to separate the text into word. But this Tableau can only separate if the data only has a text attribute. If you have two attributes like review and class label, the data will be combined because it can separate with only one delimiter. After splitting the data into word, the next step is to do the pivot table of all the separatable word into one table. We also need a stop word to exclude the stop word in the data. This must be downloaded in the internet. The stop word is for to exclude all the stop word in the data by using the Tableau where we can exclude it by insert in the filter. There are two calculate field that was produced. First, the calculation to delete the unnecessary things in the word like comma, hashtag, and semicolon, and else. The second one is calculate the percentage of the positive and negative in the review. Attribute. This class label show that the positive comment and negative comment that was given by the reviewer, it does not mean the word is negative or positive because the word may be in negative or positive sentence. These are the dashboard that I have made by using the tableau. The first figure in the dashboard is about the Parasite movie review. We can see that the Parasite and the movie word is the highest word counted in the data. This is because both of the word is the largest word we can see in the figure. In this club word, the bigger the word, the higher the number of similar word of Parasite review. We also can see that most of the word in the figure shows positive meaning. For example, masterpiece, perfect, brilliant, amazing, and else. In the figure 2, about the percentage of class level review of the Parasite movie by the reviewer, we can clearly see that most of the like reviewer like the Parasite movie because 80% of the review is a positive review and 20% is a negative review. For the figure 3, tell us about the number of word review that is sorted with the label class. The highest word in a positive class label is a Parasite word, about 403 word, and the lowest is the people, about 15 counted word. Then, in the negative class label, the highest is the movie word, about 67 counted, and the lowest is funny word, only 1 counted. This word does not mean that the word is a positive or negative meaning, but the text that have been written by the reviewer that brings the positive and negative meaning to the text. Based on the three figure, we can clearly see that the movie is a really good movie and most of the reviewer give a positive review.
Assalamualaikum. My name is Muhammad Shaidan Farhan. I will explain about modeling process using rapid miner. As can be seen in this slide, this show that three figure, which is our training modeling process. Uh, but it's not a final model since we must test using another method and another factor that can increase our accuracy of training model. So we have retrieve training data and we set a rule and we have nominal to text and we have process document from data. We have sub process which are tokenized process, steaming process, filter stock word, and transform case. We also use cross validation to create a model. In the beginning, we use naive bias and we use apply model operator and performance to see the accuracy of the model. For the first step, we start with retrieve the training dataset from Excel file using a retrieve operator. As already explained before, we split the data uh, to be training data and testing data. So this retrieve operator can load a rapid miner object into the process. For the second step, we set a class label using set role operator. This operator is used to change the role of one or more attribute. In this project, we rename the class label as a class We must set a rule of the attribute class as class label. Uh, we uh, we take a target role as a label and attribute name as a class. So step 3, we change the data type from nominal to text using nominal to text operator. On repeat minor, if dataset are in text, it will be considered as nominal data type. So the data we want to create a bag of word. So the data must be in text. So we must change the data type from nominal to text using text operator. This is the way we do a pre-processed text, or known as text processing. Text processing is the process of transforming the text into a form that is predictable and analyzable for each issue that has been addressed. In operator panel, we find the process document from data operator to create a bag of word, and we must do a sub process. We just double click the operator to create a sub process. A task here is a combination of approach and domain. We use a parameter approach and domain that already set up in a rapid minor, which is TF-IDF approach, and domain as our dataset, which is training dataset. TF-IDF is known as term frequency inverse document frequency. Was invented for document search and information retrieval, where it evaluates how relevant a word is to a document in a document set. So the sub process in process document from data operator, we must do tokenization process using tokenized operator. This process used to produce bag of word, count the occurrence of the word in the text parse, and number of times the word is repeated, and store word count. The second sub-process, we do steaming process using steam porter or steam lovings operator. Since our data is in English, so we only has two choice, which is steam porter and steam lovings. This process is used to identify the root or stem of a word and will reduce the space dimensionally. In the beginning, we decide to use steam porter as our method for steaming process. For sub-process 3, we filter the bag of word using filter stop word. Since we use English, so we must choose English operator. Stop word should be removed from a text is that they make the text look heavier and less important for analysis. This will remove the word that is unimportant, like such as I, we, and it will reduce the dimensionality of term space. So our data space will be decreased. For sub-process 4, we do synchronize all the backward in lowercase using transform case operator. So after we already create a bag of word to create the training model, of course we will do modeling process. For text mining is just the same like we do modeling for other type of data. For modeling process, we use cross-validation. Cross-validation helps us to verify the performance of our model on one dataset that we use for training and testing. It is mainly used to estimate how accurately a model learned by a particular learning operator will perform in practice. Cross-validation operator is nested operator since it has two sub-processes, which are training process and testing process. For training process, we do training model, and for testing process, we do performance of testing, which apply from the training model that already created to apply to testing dataset to find the performance of the dataset. So, in the beginning, a number of fold has been set as tenfold. This parameter specifies the number of fold, number of subsets that dataset should be divided into. For sampling type, we set as automatic as already set up in RapidMiner. The automatic mode use stratified sampling per default. For modeling process, we will use three different methods or techniques, which is naive Bayes, decision tree, and random forest using cross-validation operator. Model that gives the highest accuracy will be chosen before we proceed with the testing process, where the best model will generate the accurate result for testing process using testing dataset. For modeling process, we must do three sub-process to create a model. For the sub-process one, we choose the type of model used, such as naive Bayes, decision tree, and random forest operator. For second sub-process, we use apply model operator to pull result of model. This operator applies a model to a dataset, and the purpose of this operator is to predict and convert data by applying a pre-processing model to unseen data. As can be seen, we use a training dataset. For sub-processor, we use performance operator, the pair of apply model operator to show the performance of the model that we want to find. It can calculate the accuracy to decide whether which model can be considered as the best model using the chosen type of model. For the first model, we use naive Bayes. Naive Bayes is known as a classifier with high bias, low variance, and even with a small dataset, it can create a good model. It is easy to use and affordable for computing. Typical use cases include categorization of text, including spam identification, sentiment analysis, and system of suggestion. The accuracy of this model is estimated by 72.19%, where the model has not too accurate since the accuracy not above 80%. Those we try to use other technique to obtain the high accuracy before the process of testing will be conducted. As can be seen in the figure above, the first figure shown how we use the naive Bayes operator as our technique, and the second figure is shown that the metric and the accuracy performance for naive Bayes model. For the second technique, we use random forest. The random forest operator creates several random trees on different subsets. The resulting model is based on voting of all these trees. Due to this difference, it is less prone to overtraining. Based on this model, the value of accuracy is estimated by 76.96 and 69%, which the model is still not the best model since the accuracy is still less than 18%. So we try using the last technique, which is decision tree. As can be seen, the first figure shown how we do the sub-process of cross-validation. We use the model operator, which is random forest. And the parameter of random forest, we just use the parameter that already set up in rapid miner, which is number of trees we generate 100. And the criterion, we use a gain ratio, and maximal dip, we use 10 maximal dip. For the last technique, we use decision tree. It's known as a concurrency. Decision tree is the most common model used by other users to create a model for any type of data, such as text dataset and dataset that have many attributes to generate a model prediction. A decision tree is a tree like a collection of nodes intended to create a decision on values affiliation to a class or an estimate of a numerical target value. Each node represents a splitting rule for one specific attribute. For classification, this rule separates values belonging to different classes. Based on this model, the accuracy is estimated by 80.58%, where the accuracy is more than 80%. Compared to other methods such as naive Bayes and random forest, this technique is shown as a best model, where it has the highest accuracy, which is above 80%. So it will be chosen as our best decision tree for we will be used for testing process. As can be seen in figure 1, it shows that the sub-process of cross-validation operator, where it just the same like other technique, we just change the technique operator, which is decision tree. And for parameter, we use the parameter that already set up in a rapid miner, which is the type of decision tree. We use gain ratio. For maximal dip, we set as a 10. For confident, we set as a 0.1. For minimal gain, we set as a 0.01. For figure 3, we can see the performance, where we get from the performance operator and apply model. We shown that the accuracy for this model is 18.58%, where uh, we also shown the metric for this model. So in this slide, after we test three type of technique, we get best model based on three technique. The best model is decision tree. As already explained, it has a highest accuracy with 18.58% compared with other techniques, which is naive Bayes 72.19%, and random forest 76.69%. After choosing the technique, we try to improve our model we try to increase our model accuracy by considering other factors such as changing type of streaming in process document from data operator uh, and other technique. So uh, for the first technique, we try to change the type of streaming in process document from data operator. First, we have two types of streaming, which is stream porter and stream lovings. In the beginning, we already use stream porter where it gives for decision tree 18.58%. So we change into stream lovings for the steaming process. By using steam lovings, the training model gives 78.92% accuracy. The accuracy is decreased, so it is not uh, the best model since if we still use steam porter, we will get the highest accuracy. Thus, we decide to still use the steam porter operator since this method give the highest accuracy compared to steam lovings. As can be seen in figure 1, it shows that the accuracy when we use steam lovings as our steaming process, where it gives the accuracy is 78.92%. So we just change the operator steam from steam porter to steam lovings and use other operator just the same like in the beginning. Try other factor which is type of vector creation or known as step processing approach. In the beginning, we already use TF-IDF where it gives accuracy by 18.58% using decision tree model and steam porter. So we try using other type of vector creation such as term frequency and term occurrence. The term frequency is known as how often a term or word occurs in a document or dataset. From this type of text processing approach, we estimate that the accuracy of that model is 75.09% accuracy, which is decreased from the TS-IDF approach. So we try the other approach which is term accurate. Based on term accurate is based on the rate of accurate that word occur in document or dataset. From this type of approach, it gives 73.09% accuracy. From term frequency and term occurrence, it gives the lowest uh, model compared to TF-IDF. So we decide to use TF-IDF as our approach since the accuracy is higher than other approach of text processing. As can be seen in figure 1, it shows that the performance when we use a term frequency as our text processing approach, it gives 75.09 accuracy. For the second figure, it's shown that the performance when we use the term accurate as our text processing technique, it gives accuracy by 73.09%. So from this, we already decide that to still use TF-IDF as our text processing approach, since it gives the high accuracy for the model when we want to use for testing process. For the last factor, we try to change the number of folds for cross validation. we increase the number of fold for cross-validation operator from the process to create a model, which is from 10-fold to 20-fold, to increase the accuracy of the training model. Uh, from these changes, the accuracy is given by 81.01%, which is the highest accuracy compared to when we use 10 fold as our number of fold for cross validation operator. Uh, those we decide to use 24 for the cross validation parameter. The type of the other so from this model we already finalized the final model that will be used for training model, which is the type of teaming we will be use team porter, vector creation which is TF-IDF, and we decide to use 20 for cross validation, since all these type of operator that has been applied in the model will create will build the model with 81.01% of accuracy, which is the highest value accuracy compared to other technique. So the other parameter we just decide to use the standard parameter that already set up in RapidMiner. As you can see in figure 1, this shows the accuracy, which is the performance model when we use 20 for the cross validation parameter that give 81.01%. For parameter, we change the number of fold to 20, and we still use a sampling type as automatic. So, after considering all the factors and the technique, we already obtain the complete training model and the best training model that will be used for testing process, where we use the standard model that already discussed in the previous slide, and we use the type of technique which is decision tree, and we still use steam porter as our steaming process. Since the steam lovings give the lower accuracy compared to steam porter, and we use cross validation parameter as 24, since it gives the accuracy by 81.01% compared to using 10 full, which only give 18.58%. uh, the type the type of process document, the parameter of process document from data, we use the type processing technique, which is TF-IDF, same term occurrence and term frequency still give the lowest accuracy compared to TF-IDF.
So after the training modeling process is being done, we proceed to the testing modeling process, which involve the testing data. First, we retrieve the testing data, and then we can copy the process from multiply to the process documents from the training model. Later, we apply model between the cross validation and process documents. Then we apply performance. Then we run. The first picture is the sub-process of cross-validation operator. In this process, we use the decision tree model in training model, and then later we apply model in testing, and performance. Next is the sub-process of process documents from data operator. We use the operator tokenize, stem porter, and we later then filter the stored words. So step 1, we retrieve the testing datasets from the Excel file using retrieve operator. Then the retrieve operator loads a rapid minor object into the process, as shown at the picture at the right side. So second step, we set the class label using setRole operator. As we know, this operator is used to change the role of one or more attributes. Then we set the attribute class as a class label. As shown at the target role, we select the label. Next step, we change the data type from nominal to text using nominal to text operator. So before this, the data type of review on Parasite 2019 is polynomial. But then the data type become to text. Step 4 is the pre-processed text. Text processing is the process of transforming the text into a form that is predictable and analyzable for each issue that has been addressed. There are several sub-processes in this step 4, which are tokenization process using tokenize operator. Second process is the stemming process by using stem porter or stem Lovins operator for only English issue or reviews. Next, we'll filter the bag of words using the filter stored words. Lastly, we synchronize all the bag of words with lowercase letter. Okay, step 1, we apply the model using apply model operator. This operator applies a model on the dataset. Next, this operator can enhance the process in applying training model into testing process. The figure at the right side is the example and the explanation from our model. So the next step is performance operator. We use the operator to see the testing dataset's performance and the accuracy. This operator delivers a list of performance criteria values. These performance criteria are automatically determined in order to fit the issues addressed. So the picture at the right side is the figure in our model. So this is the result of testing model evaluation. So the accuracy is 81.11%, which we successfully achieved the accuracy above 80%. So next, the precision is 87.31%. Next, the result of recall, which is 91.49%. And the picture above is the performance vector of the testing model evaluation. So in this slide is the explanation of the testing model and the result. By using the manual tagging, 29 review is negative review and 188 review is positive review. So based on the testing model, the accuracy is estimated by 81.1%, which shows that the model is suitable to use as the best model for data testing. The matrix shows that 25 review false negative from the total negative review is predicted to be positive, and 16 review false positive from total positive review is predicted to be negative review using the training model. So, based on the value of precision and recall, this has been estimated by 87.31% and 91.49% respectively. So, this shows that the chosen model, which is decision tree, by using stem porter as stemming process and TF-IDF as the text processing approach, vector creation. Lastly, this model has used 20-fold cross-validation, which provides high accuracy and is selected as the best training model and ideal for testing processes, where the accuracy of the testing datasets is also greater than 65% accuracy.